Okay, this is the second chapter of the Transmark book, and just like the first chapter, we'll go through this very rapidly. Indeed, this chapter is very simple. I'm surprised that they devoted an entire chapter to it, to the topic. And I will take this opportunity of presenting some information about numbers in general. This is on multiplier, diviser des nombres relatifs. What are nombres relatifs? We'll just discuss that. So it's multiplying and dividing relative numbers. Relative numbers is the wrong term in English. I'll tell you what the equivalent term is. Okay, so let's just start by discussing droite graduée, in English, number line. Do you know what this is? Of course you do. This is a line, a horizontal line with 0 at the center and positive numbers on the right. 1, 2, 3, 4, 5, 6 goes on and on and on and on and on to very large number, to as big a number as whatever number you can think of is on this line. And here on the negative side, on the left, traditionally the left is negative, the right is positive. You get -1, -2, -3, -4, -5, and again to infinity. Minus infinity on the left, plus infinity on the right. I tried to avoid using the term infinity, but infinity refers to a mathematical concept which is hard to define. It just means the biggest number you can think of, or the biggest number there is. And since there is no biggest number, it's a little confusing. But in the next few minutes we'll come back to it in another example. Now in this droite graduée number line, I've put, if you see, my paper has got squares on it, so for every one square I put one number, 1, 2, 3, but I could compress it or expand it. So I have another, I can draw it like this also, where every 2 squares is 50, so I get 50, 100, 150, and on this side 50, minus 100, minus 50, and so on. But realize that this number line is the same as this number line, only this is zoomed out or compressed, whichever way you want to put it. Any number that you can put on this line, you can put also on this line. Here if you put 10, it would be somewhere here. Here if you put 10, it will be somewhere 1/5 of this distance. It would be somewhere there. 10 would be there. In this case, 6, 7, 8, 9, 10 would be here. Okay. So a droite graduée or a number line is used to indicate graphically any number you can think of. Okay, so now let's come to nombre relatif, which is multiplier, diviser des nombres relatifs, the name of this chapter. Nombre relatif simply means real numbers. Now you will wonder why I'm using the adjective real numbers. Are there anything like unreal numbers? All numbers are real, and the answer is there are some numbers which are called imaginary. So that's also an unfortunate term because they're not truly imaginary. You might come across them later on your mathematics studies. For the moment, assume that nombre relatif means any number, positive or negative, 0 included, not including infinity or minus infinity, because those are not numbers. Okay, so the definition of nombre relatif or real numbers, all positive and negative numbers including 0. So 1 is a real number, nombre relatif, 2, 6.7, minus 0.8, minus 0.00000000063, 9, or whatever this number is, this number, comma, 1, 2, 3, 4, 5, 6, So this number and all of these numbers are real numbers or norm relative. Any number you can think of is indeed a norm relative. Okay, so I'm just going to take a few basic information about numbers and I'll present them in this video, even though the scope of this chapter is slightly limited. So, order of algebraic operations. Now, by tradition and by definition, we have defined this as the order of algebraic operations. It's called PODMAS. In Indian languages or in India, they sometimes change this P to B, so it's easier to remember. It becomes Badmash, which in many Indian languages means naughty or scoundrel. So P stands for parenthesis, or if you want to change it to B, you can say brackets. O is order, which is power, or in French puissance, à la puissance, to the power of. D and M, they refer to division and multiplication. A and S refer to addition and subtraction. So this, when you have a number, a calculation to do, then first you do whatever is inside the parenthesis, then the next importance you give to taking to the power, then division and multiplication. I've joined them. You can do division and multiplication are actually at the same level. You can do multiplication first or division, it doesn't make any difference, and the same with addition and subtraction. So if you have parentheses, you write brackets. That means if you write 2 plus 3 like that, you have to do this before you do anything else. Similarly, order puissance, 6 to the power 2, 6 à la puissance 2, that is the next thing. Okay, so I have a worked out example here. Now I'm sorry if this is very elementary to you, but just best that we repeat it, just in case there are some things that you have forgotten or you didn't know at all to begin with. So let's say I have this calculation to do, 2 plus 3 within brackets to the power 6 plus 3 into 4 plus 2 again within brackets into 16 minus 12 again within brackets to the power 2. So the first thing we do, because we say do the brackets first, we solve it. We write 2 plus 3 is equal to 5. So this becomes 5 to the power 6. 3 into 4 plus 2. So which should you do first? 3 into 4 or 4 plus 2? No, here you see multiplication comes before addition. So you first do the multiplication. It becomes 12 plus 2, you leave it for the time being, into 16 minus 12 to the power 2. 16 minus 12 is 4, so it becomes 12 plus 2 into 4 to the power 2. So now we can go to the next step. We can do 5 to the power 6. You plug this into your calculator, you will get 15,625 plus 14. This is 12 plus 4 is 14. You have to do it because it's in brackets, into 4 to the power 2. Into 4 to the power 2, you can write it like this. Then the next step is this 15,625 remains plus 14 into 4 to the power 2. What should you do first? Should you do 14 into 4 or you should do to the power 2 first? Here you see power, that is order has precedence over multiplication. So first you do 4 to the power 2, you get 16. 4 into 4 to the power 2 is 16. 4 into 4, 16. So now you have this. Now what do? Do you add 14 first to this or you multiply 14 into this? Again, multiplication has precedence over addition. So you do 14 into 16 first. So you get 15,625 plus 224. 224 is 14 into 16. Finally you add it up and you get 15,849, which is the answer, the correct answer to this, assuming I've done the multiplications and stuff correctly, which I think I have. Okay, so this is the order of algebraic operations, PODMAS, or if you like to be think in Indian languages, you can turn that into a B and call it Badmash. Okay, so now the first in-video example, homework, 4 into 3 square minus 60 over 3 plus 2 plus 3 square in brackets to the power 2 plus 63 divided by 3 to the power 2. That's not 32, that's 3 to the power 2. So do this and send me the result. This is again, this is not going to be graded, this is just to ensure that you watch the video. But please do it step by step. Don't just send me one number, just do it step by step as I have done it here, so that I know that you have really understood. I'm sure you know all of this, but still, just to make sure. Now, some simpler calculators do not follow PODMAS. So if you type this into many calculators, especially the simple calculators, 4 functions that you find at the cashier of shops when they want to calculate things, this will be 2 plus 4 into 3. The correct is 2 plus 12. 4 into 3 first you do, then you add the 2, then you get 14. But if you start doing this on one of these cheaper calculators, wait a minute, I might even have one. Okay, so I have this simple calculator here. I don't know whether you can see the display. Let's see. So if I do, what is it? 2 plus 4 into 3, 2. First let's switch it on. So I do 2, then I do plus, then I do 4, then I do into, then I do 3, and then I press equals, and I get 18. So you see 6 plus 3. So what it did was, first it did 2 plus 4, that is 6, then it multiplied by 3, it gave me 18. So this calculator is one of these older calculators, and you know, most of these what they are known as 4 function calculators, calculators that are not scientific calculators, will give this sort of error. So you have to be a little careful of this. Now let's come to addition and subtraction of negative numbers. So if you have 12 minus 14, you get minus 2. If you take minus 14 minus 16, you get minus 30. I'm not really going to explain this, but a simple way to think of it is that if you take a number line, for addition you go to the right, for subtraction you go to the left. So if you have 2 and I want to add 3 to it, so 1, 2, 3, 2 plus 3 will give me 5. If I have 3 and I want to subtract 8 from it, so a subtraction go this way, 1, 2, 3, 4, 5, 6, 7, 8 will give me minus 5. 3 minus 8 will give me minus 5. But that's one way of looking at it. Now we come to the actual topic of this chapter, which is multiplication involving negative numbers. So basically, if you have one negative number and one positive number, you get a negative number. 20 into minus 2. I am putting brackets here because you normally don't write two mathematical operations one after another without separating them by brackets. So 20 into minus 2 is equal to minus 40. But if you multiply two negative numbers, you get a positive number. So I am just written the plus there just to emphasize it. But for positive numbers, you really don't need to write the plus. So minus 20 into minus 2 is equal to plus 40. Two negative numbers here. And I will just now give you a proof for these. How does this work? I will give you a proof. I will prove to you that if you multiply two negative numbers, you will get a positive number. Just in the next 2 minutes I will show you that. And the same thing applies for division. If you divide 20 by one number by a negative number, you get a negative number. 20 divided by minus 2, you get minus 10. Similarly, if you took the numerator as negative and denominator as positive, minus 20 over 2, you get minus 10. Same as this. If you take 20 divided by 2, you get 10. Of course, this we know. Everything here is positive. But if you take minus 20 divided by minus 2, you get 10. You can think of it as the minus sign cancels out. In a way, of course, the word cancel is a word that I don't like using because it is it is not a mathematical term, but the minus, see, 20 is, minus 20 is what? It is actually 20 multiplied by minus 1. What is minus 2? It's equal to 2 multiplied by minus 1. So minus 1 and minus 1 on the top and bottom will simplify, leaving us with 20 over 10, which gives us 10. Okay. So now that we have established this, I will actually prove this to you. So it's an interesting and simple proof. Let's say, how much is 3 times 0? So 3 times 0 we know is 0. You take 0 as many number of times, you'll still get 0. If I took 500 times 0, it will still be 0. If I took 5 million times 0, it will still be 0. So 3 times 0 is 0. How can I write 0? I can write 0 like this. So 3 into 4 minus 4. So instead of writing 0, I am writing 4 minus 4. I could have chosen any number here. I could have written 500 minus 500. I could have written 5 million minus 5 million. I could have written 1 minus 1. But just at random, I chose 4 minus 4. So 3 into 4 minus 4 is 0. Yeah, this is obvious because 4 minus 4 is equal to 0. So from this I can write this. Now I can write this 4 minus 4 as 4 plus minus 4. So here, instead of saying 4 minus 4, I am saying I am adding minus 4 plus 4. So I am writing 4 plus minus 4. Have you understood this? 4 minus 4 is the same as 4 plus minus 4. So basically I have done nothing. I have just brought it down to this. Actually, this should come. Just 1 minute. I should strike that out. I wrote that on this wrong line. This is where it comes. So now we apply the principle of distributivity. So what is distributivity? Now look here. Distributivity means 2. If I write 2 into x plus 3, it is equal to 2x plus 2 into 3. First you do 2 into x, then you add 2 into 3. Why do you add? Because there is a plus sign there. So 2x plus 2 into 3. This is equal to 2x. 2 into 3 is 6. So 2x plus 6. This is known as the property of distributivity, because you are distributing the multiplication amongst two terms. I'm showing it to you now, but I just realized that the next chapter in the book is just about distributivity. Anyway, when we come to that, we'll see. So what I do is I apply distributivity to this. 3 into 4 plus 3 into minus 4. So 3 into 4 I write here, and then I write plus, this is the plus here, 3 into this term, which is minus 4. So 3 into 4 plus 3 into minus 4 is equal to 0. What I have done here is this, I have used the same principle as what I have done here to simplify it to this. Not simplify it, to expand it to this. What is 3 into 4? We know is 12. What is 3 into minus 4? Forget it. Let's not see what it is. Let's say we replace this calculation by a box. So 12 plus whatever is in this box has to equal 0. So 12 plus what will equal 0? Obviously, what can I put in the box so that I get 0? Obviously the answer is minus 12. 12 minus 12 will give us 0. So what I write here is 12 plus minus 12 is equal to 0. So from this I can show that 3 into minus 4 is equal to minus 12. Therefore these 3 dots signify donc, or therefore 3 into minus 4 is equal to minus 12. This is what we wanted to prove. I am multiplying a positive number into a negative number, I will get a negative number. Okay, so this is multiplying one positive number into one negative number, I get a negative number. This is quite understandable that if I have 50 apples and I remove 3, then I have 47. But if I remove 3 times, then I have 41, because I have subtracted 9. 3 into minus 3 is equal to minus 9. When I subtract from 50, 9, I'll get 41. So this is more or less understandable, but two negative numbers give you positive is a little difficult to understand, but we will now prove that. So let's start with this. Minus 4 into 0 is 0. This we know because anything into 0 is 0. Even a negative number into 0 is 0. Okay, let's take, but 0 is equal to 5 minus 5 or 500 minus 500 or whatever number you can think of minus the same number. So I could have said 12.6 minus 12.6, but I just chose 5 minus 5. Again we rewrite it as 5 plus minus 5. Instead of saying 5 minus 5, I'm writing it as 5 plus minus 5. Then I use the distributivity rule. I multiply this by this, then add this into this. So minus 4 into 5 plus minus 4 into minus 5 is equal to 0. Are you with me? Well, I hope so. So minus 4 into 5 is minus 20. How do I know that? Well, we just proved it there. You multiply one positive number into one negative number, you get a negative number. So minus 4 into 5 is minus 20. Let's call this, let's replace this with a box, is equal to 0. So what is the value of this box? What when added to minus 20 will give 0? The answer is plus 20. I'm again writing plus to emphasize that it is positive, but for positive numbers you really don't need to write the plus sign. So from here we can say therefore minus 4 into minus 5 is equal to plus 20. So we multiply two negative numbers, we get a positive number. So now this is the second problem I want you to do. Again you do it step by step, don't just write one number as an answer and send it to me. 48 into minus 4 plus minus 6 into minus 3 plus minus 1 into minus 6 into minus 8. You have to follow these rules and you have to follow the PODMAS rules. Okay. So now just because we have a little time, I am coming to a concept that creates problems for everyone. When I say everyone, even for me. So this is the concept of division by 0. So mathematics gets around this problem. Now if I tell you what is 20 divided by 0, you'll get a little confused. So mathematics gets around this by saying that division is not defined. The operation of division itself is not defined if you try to divide by 0. So division by 0 is not defined. So division by 0 is not defined. But what does it actually mean? Some people say that 10 over 0 if I do is equal to infinity. Now again, infinity is not a number. Infinity, by the way, is written like this. It's like a figure 8 on its side, but this side is not joined. It's almost joined but not joined. Here. There, it's focusing now. So we'll look at it in a slightly different way. We'll do it the way it is done in mathematics. So let's say I have 100 chocolates. I want to distribute them to a number of people. So let's say that I will give 2 chocolates to each person. How many people can I give chocolates to? So I have 100 chocolates. I want to give them to people, and let's say students, and if I divide them, if I give everyone 2 chocolates, how many students can I give chocolates to? Well, you know the answer to this. If I do 100 divided by 2, everyone I'm giving 2 chocolates, it's to 50 persons I can give the chocolates. Very simple. Okay, you decide that instead of giving 2 chocolates, you'll give 1 chocolate per person. So you divide 100 divided by 1, you can give to 100 persons. Yeah, very simple. Now you decide you'll give only half a chocolate bar to each person because you want to give to more persons. So if you divide 100 by 0.5, you'll get 200. So 200, because you see 200 into 0.5 gives you 100. Here 100 into 1 gives you 100. Here 50 into 2 gives you 100. So basically what you're doing is you're now giving half a chocolate bar to each person. So you can give 100 chocolate bars, you can distribute among 200 persons. But you want to be more fair, you want to give to a bigger number of people. So you say, okay, I will break the chocolate bar, each chocolate bar into 10 pieces and give 1/10 of a chocolate bar to each person. So how many persons can you give 100 chocolate bars to? 100 divided by 0.1, 1,000 persons. 100 chocolates you're giving to 1,000 persons, because each person you're giving 0.1 of a chocolate bar. So you see what I'm doing, I'm reducing this number 2, 1, 0.5, 0.1, and as I'm doing this side the number is increasing, 50, 100, 200, 1000. Now let's say you want to give it to many more people, but you only have 100 chocolate bars, so you decide to divide it by 0.01. That means each chocolate bar each person you want to give only 0.01 of a chocolate bar. So you divide 100 by 0.01. You see you can give it to 10,000 persons. And you say, okay, what the heck? I'll give a tiny sliver of the chocolate bar. So you'll give you, here it was 100, here it is 1/10,000th of a chocolate bar. Each chocolate bar you're going to break into 10,000 pieces, and then you're going to distribute your 100 chocolate bars. Then you see you can give it to 1 million persons. 1 million, 1 followed by 6 zeros, 1,000 thousands. So 1 million. So what it means is if you divide a number by an ever smaller number, you'll get an ever bigger answer. We started with 2, we got 50, we reached 0.0001, and we're up to 1 million. So essentially, as you divide by a smaller and smaller number, you get a bigger and bigger answer. So if we take a general form, if I am dividing A by B and the answer is C, then we can say, and this is the right way to say it in mathematics, as B tends to 0, as we take it towards 0, as B tends to 0, C tends to infinity. C, as we take B to 0, C increases to infinity. Even though division by 0 is not defined, 10 over 0 means nothing. You can say that if A over B is equal to C, and as B tends to 0, C tends to infinity. This also means, the one condition here is that A is itself not 0. Because if you think 10 over 0 is something difficult to understand, then 0 over 0 is something even more difficult to understand. Okay, so we will stop here. Just send me these two problems, the two problems I mentioned in this video, and I will, in my WhatsApp below, I will tell you by when you have to send it to me. Okay, this is a slightly long video, it's almost 30 minutes, but I think it is useful, and you might have learned something from it, and if not learned, at least got a revision. Okay, I stop here.